Hey guys, welcome to my RxJS 2021 crash course. Now I know that there are a couple of videos that try to cover this already out there on the internet. However, some of them are quite old, so the examples that they give don't even work anymore, or maybe they're just not that comprehensive. So this video attempts to solve both of those problems. So if that interests you, then let's begin. Now, RxJS is actually part of an even bigger group of libraries called Reactive Extensions or ReactiveX, and these libraries attempt to bring reactive programming to a plethora of different programming languages. And reactive programming itself is built on data streams, and these streams can be created from anything so long as they can create a sequence of values. So that's why all those things are listed as things that can be turned into streams, although they aren't streams in themselves. And here are the different ReactiveX libraries available for the various languages. As you can see, we're going to be using RxJS for JavaScript for this tutorial, because JavaScript is the most popular programming language, and it has been for some time. As for a stream, it is a sequence of values in time, so it's very simple. So therefore, an array of 1 to 5 can be turned into a stream. And things that subscribe to streams to receive the data being transported along it are called observers. And what they subscribe to are called observables. Now, it's important to not conflate observables with streams. Rather, observables are a pattern that RxJS uses to represent the data in a stream and give us something that observers can subscribe to receive data as they come out of the stream. Now, data begins their journey in the stream when they're emitted by observables, and eventually these values will reach the stream's observers through the observer's subscription. But along the way, they can pass through operators. Operators are functions that perform logic at some point along the stream, and they can do anything from transforming incoming data to creating streams within observables. And some streams end because they have run out of values, others end on error, and others remain open indeterminately, like an event listener, for example. So here is a picture that tries to represent a data stream. So data that's just been emitted will go through the purple pipe, which is a part of the stream. And then they may pass through an operator, although not all streams have to have operators. And this operator, an example what it might do, it might format the data so that it's in a correct formatting. And once it's been processed through the operator, it will continue its journey in the stream through the yellow pipe this time, and also in the correct format. So they will then reach an observer's subscribe callback function, in which case we will be able to receive the formatted data and work with it just through normal JavaScript logic. And it's also important to remember that, say if our stream was derived from an array, for example, then the individual items in the array would be transported down the stream in individual data packages, one for each item in the array. So it's just important to remember that they're not all bundled together and then just sent down in one. Although that doesn't mean that they will be sent in order of how they were ordered in the array. It does mean that they will be sent as individual data packets, so it's important to keep that in mind. We will now go on to learning how to set up RxJS in a vanilla JavaScript project using webpack as the bundler and babel as the compiler. So here we are in a new empty project folder. First thing that we would do is we will launch a terminal inside this project folder. I'll be using git bash because it seems to be less error prone. The first thing that we will do is we will initialize npm inside of our project folder, and we'll use the y flag just to speed things up a bit. Once you've initialized that, we can install the dependencies that we need. First thing that we'll do, we'll head over to webpack and we'll copy this command here. And for some reason Ctrl-V doesn't seem to be working in git bash, I'm not sure why, so I had to paste it in like so. And this save dev flag here, it's not essential, but it is recommended, and that's because we only need these dependencies when bundling our application. Once our application has been bundled, we can host it without the existence of any of these dependencies. So That's the reason why we're using that flag, just because it would be unnecessary to actually have these dependencies inside our bundled application, which is actually hosted, because they don't do anything on the bundled version. And then we'll have webpack CLI as well, so that we can run webpack commands. And then we'll need to go to Babel compiler, go to setup, and then we'll click webpack because that's what we're using, and we'll copy these because we need to install them. And then we will copy this one as well because we need to create the Babel's config file. So with all these dependencies in our install statement, we'll press enter and wait for all these dependencies to install. Once installed, we will launch up our terminal inside this project folder, and we'll create a source directory because the JavaScript file that we will create inside the source directory, this one here, this will be compiled with webpack, and the outputted file will be able to host on a HTML file to host all of our RxJS logic. And inside we'll write out some content, and this is the reason why we need to compile this file with Babel, because these import statements don't actually work without our browser doesn't know how to interpret them, so we'll need to compile them with Babel into something that the browser can actually read. And one thing that I forgot to do actually, we need to install, but not as web dependency this time, we need to install RxJS, of course, so that we can actually use these. I don't know how I forgot to do that, but yeah, these won't work even if we do compile it if we don't install RxJS. So we install it like so, and then we will say we'll create a stream of 3 items, so 3 pieces of data will be passed down the stream, and we include operators in streams. Don't pay too much attention to this at the moment. This is just an example. Yeah, we imported that. Yeah, this is just an example, so don't worry if you don't get this, because we're only having this just so that we can see that it's working or not. And then we subscribe to this like so, and then we say console.log data. So it's simply, so we're just, all we're doing is squaring the number, so we'll say 1, 4, and then 9, and that should be logged here. So that's all that we'll include in this file. Next thing that we'll do, we will need to create a webpack configuration file, so that we can say we need to pass the app's JavaScript file to bundle it with Babel to process it with the Babel compiler. As for what we'll export, we'll just copy this, we'll get it from here, and then we'll make some changes to it in a second. So none of this will change, none of the module, that won't change, but we will add entry. So entry is the file that we want taken, or multiple files if entry was assigned an array. In our case, we're only taking in one file, and that will just be the app.js. That's the only JavaScript file that we want to compile with Babel. And then we'll include one more property, and it's important that it's below module, and that's output. So where do we want to output the compiled app.js file to? Well, first of all, what do we want to call the compiled app.js file? We want to call it app.bundle.js. Bundle, because it's been bundled through webpack using the Babel compiler. And the path, this needs to be an absolute path. So to create an absolute path, we will require a path which comes with Node.js by default, so you can just require automatically like that, and then we'll say path.resolve, and that will, the resolve method with dir name will automatically link to our root project, and then from that we'll just say in the dist folder, which will just be created alongside the source folder automatically when we do end up compiling our files with webpack. So that's all there is for this file. We can close it now. Next, we'll need to create a Babel configuration file like so, .json, And the reason why we need to create this is because we said preset. We need to define this preset, otherwise it doesn't mean anything. So again, it's handily got what we need to write there, so we just copy it from the Babel's actual documentation. Next, what we'll need to do is we'll need to create some scripts for webpack, and we'll create 2 of them. One will just be build, and we'll use webpack in mode development. Both of them will be mode development, and all build will do it will simply build our app.js and then output it within the dist folder. And watch is the one that we'll actually be using because it's more useful, and it's simply the same with the W flag. And what watch will do is it will automatically rerun webpack to bundle the app.js file every time we make a change to app.js once we've run the watch command. So that's very useful. And we'll actually now run that watch command because it's the better of the two. Because remember, if we didn't watch, then we'd have to rerun the build command every time we made changes to our app.js file to get those changes actually reflected in the file, in the bundled file that's hosted on our HTML file, which we haven't created yet. So we'll say npm run watch, and this shouldn't exit immediately. It should just run. Yeah, it says successfully. I know you get these yellow errors. Well, they're not errors, but you know, they're kind of yellow messages, but we know that's working because it says successfully. And also we've got this app.bundle.js, so that's good. We can now create a HTML file and link to that bundled file, because that's the one that is actually compatible with our browser. So we'll link to it like so because it's in the dist. Put it in like so, and then we will host this with live server, a VS Code extension. We'll go to a console to see. As you can see, we've got 149, so it's working. And yeah, so that's a successful setup. We'll now go on to the basics of RxJS. So the first thing that we will cover is we will cover how to make subscriptions from events. So to do this, we'll need to import from event. We can delete this now since that was just for testing purposes. And we'll apply the event to the document, and it will be a click event. Whoops. And this is literally exactly the same as writing document.add event listener, click, and then writing our code in the callback function. This callback function here is essentially the same as the subscribe callback function, which we can have on the event stream. So we will actually use a pipe, an operator, and we include it in the pipe method because that's where we always include operators. Sorry, what am I on about? Not operator, so it's scan. It scans the operator that we'll be using, and it works in a similar vein to the reduce method in JavaScript. So essentially it just adds on 1. It starts at 0, so the subscribe method will take in 0. The first time this is called, the subscribe method receives a value, it will be 1, because it starts with 0, and then 0 plus 1 obviously is 1. And next time the subscribe method receives a value, it will be 2, because it was previously 1, and then obviously they added 1 to it again, and then so on and so forth. But anyway, rather than me explaining that to you, I could just show you, obviously, and I'll be able to show you easily because we've already got the watch command running. So if we just save this now, obviously it's still running, so hopefully if we go back to our console, then we should, and refresh just in case, we should be able to see we're getting nothing now. We clicked 1 times, 2, 3, 4, and then etc. Obviously I won't bore you. So that's a very simple way of creating a stream from an event that's triggered. A value is emitted when the event is triggered. Now we will cover creating a stream from an array. So we'll do it now. And what we'll need to do this is we'll need to import from RxJS like so, and then we pass in an array. So the array that we'll pass in, again very simple, And then after that, we could simply subscribe to it because it's now a stream. And our streams obviously have the subscribe method, as do they also have the pipe method on it as well, so that you can insert our operators. And so this should literally just display every single item in the array. That should just be logged as individual items in our console. If we go and refresh, as you can see, as promised. Alternatively, I mean, technically it's not creating a stream from an array, but it's creating a stream from a list of values. We could use the of method like that from RxJS, and that should do the same thing. And obviously we need to delete that because we've already imported it, so I made a mistake. But anyway, if you refresh, as you could see, is that exactly the same thing as promised. We can also create our own observables from scratch, and we can emit values with the next method. If I show you, we need to import observable, and then we can declare one with new observable because it's a class that we can instantiate an object from. And then we have access to the subscriber, and we can use the subscriber to emit values. So we say next and then 1. So doing this is exactly the same as saying of 1 2, creating a stream that way. Just of method and then 1 and then insert 2 as the next item is exactly the same essentially. So we'll do the same for 3. So if we log this, and if we subscribe to it, and then we log all the values, then we should see that a list of them being displayed as individual items. However, just to liven things up a bit, we use a set timeout here, and we'll delay it for a second, 1000 milliseconds, same thing. And then we say we'll send the next one along. So this will be staggered essentially. And after that, we say subscriber.complete, and I'll show you why that is important later on. But now we can actually subscribe to observable. So if we say subscribe, not subscriber, sorry. As you can see, we should get, hopefully if we refresh, 1 2 3, and then we wait a bit, and then 4. So that's how that works, and I'll show you there are other things that we can do as well, such as if we have a second argument to the subscribe method, then we can, that will log the error, and then a third one, so I don't know what, yeah, a third one will be called onComplete. So since we included this subscriber.complete, we should hopefully get completed printed to our console. And so if we refresh, 1 2 3 4, and then completed as promised. As for the error, well, we could throw an error like so. And obviously anything below just simply won't get. I know this is a bit hard to read, sorry. Put that there as well. So now anything we refresh, again 1 2, this is an error, exactly what we wrote there. So again, the subscribe method, I don't know why that's crossed out, but this is, as you can see just by the fact that it's working, this is actually genuine syntax that we can use. It can take in a free, I don't know why that's there actually, it doesn't need to be there. It can take in 3 callback functions, as I've just demonstrated to you. Okay, well now I'll talk about how to create streams from promises. So to do that, we'll do that with a bit more of an elaborate example. We'll have this loading text that displays in the browser, as you can see. If we, oh, whoops, that's not even, whoops, spelled that wrong. That should work now, as you can see. Loading, and it will eventually disappear when this promise resolves a value. Obviously we need to create the promise, promise first. And obviously reject happens when we want to throw an error, but hopefully we won't have to do that. Well, I mean, you shouldn't, there's nothing really here that will cause an error. because all that happens is after 3 seconds are up, as done with the set timeout method, when the 3 seconds are done, we will resolve a value, which means the promise will actually return the value that it promised to return, hence the name promise, because it promises to resolve value. And we'll just type in some random dummy data, doesn't matter because it's all demonstration. None of this data really makes any sense. I don't know why title message an 8, again it's not meant to make sense, just an example. And the way that we will create an observable from this promise, we will import from the from method, and then we'll simply say from the promise that we created and should assign to a constant. Well, I mean, we could just copy that in there, but it's better if we do it like this. And so now this is now an observable. Meaning that we can subscribe to it. So when a value is resolved, we will get access to the object that it resolved through date. Obviously that will only happen 3 seconds after the document has been loaded though. And 3 seconds after the document is loaded, we will get rid of the loading text because it's finished loading, because we finally got a value back. And then, by the way, you're most likely to the reason why we're using resolve is because, sorry, not resolve. Essentially, we are just mimicking the behavior of a GET request or a request to a server. Essentially, because obviously that doesn't happen synchronously, you have to wait for the server's response, etc. So anyway, when we get back the object, we will loop through the object's keys using a for in loop, and then we'll say insert a JSON, okay, I keep getting that wrong, and then we will insert before begin, so that it stacks up on top of each other. It starts at the very bottom as the last child of the body, and then gets progressive, and then it just stacks up on top of the last child. That's already there. And we'll put a paragraph in there like so. And now if we refresh, loading, wait 3 seconds, loading, okay. Oh yeah, data key. Sorry, yeah, this is wrong, I don't know why I said date. Yeah, I thought so much. See, I keep making silly mistakes when I do tutorials because it's a bit stressful, but again, as you can see, here we go. That's the behavior that we ultimately wanted. Now I'll actually comment out this example because we'll come back to it later on. For now though, we will talk about interval, time and range. The way that we'll import interval. We don't need everything at once. And this will essentially be something that this is actually an observable that it returns. And this will emit a value every 1 second because it's written in milliseconds, 1,000 milliseconds, it's a second. And then from it we can subscribe. And this should just be literally just a number that increments, sorry, yeah, val like so, again with the errors, I don't know. But if we log, it should say 0, 1, 2, 3, 4, yeah, as you can see, it's pretty self-explanatory. If we wanted to have an endpoint, so say like stop incrementing after 5, then we will import this take operator like so, and then instead of subscribe, although we will eventually subscribe, we will use the pipe method like we always do, and then inside we will use the take operator, which is where we imported it from operator, and actually we'll make it to count to 3. So the reason why it's 4 is because we want the first 4 values. So, and it starts counting at 0. So if we refresh, hopefully it says 1, 2, 3, and then it won't increase after that. So as you can see, it stops at 3. So that's good. And using the scan operator that I already showed you, we can use it here to overwrite the default logic. So although it starts at 0, it gets +1 the first time, and so now it will count only for 3. So it'll start at 1 and then go to 3. So yeah, that's the logic that I just said would happen, and it did, so that's how you do that. We'll get rid of pipe for now, because we're now going to talk about timer. So instead of interval, we'll use timer. It's actually very similar to interval. So the first argument is the delay between from when the page is loaded to when it will start emitting its first values. Second argument will be the gap between emitting the values. So we wait 1 second, and then only then does it start actually emitting values. And lastly, out of these sequences, we've got range, which very simply will go from a range. So we say start counting at 1, and then we stop counting at 3. So that will simply just go from 1 to 3. And all of these will come at once. Actually, they won't be delayed, as you can see. That just prints out all at the same time, but still as individual values. We'll now go back to, we'll delete this and delete some of the things that we don't need as well. We will need from actually. We'll now talk about the map operator, and we'll go back to our original example. So what we'll do is we will use the pipe. So basically what the map operator does is that it modifies the original data that's coming through in a way specified. So let me just sort this out. So for example, we'll just get the we'll get the age, and so now because it's no longer an object, we need to get rid of this. And by the way, it has to be the data that's returned has to be the original data. It can't be like a new object or anything like that. It has to be a modified form of the original data, otherwise we won't be able to receive a value in the subscribe callback. And so now if we save this, remember we're still using the watch, so it's still update. If we just wait a second, as you can see, we're getting back 12 now, because that's the only thing that we extracted. Alternatively, a much easier way of doing this would be to use pluck instead of map, which does a similar thing. It just makes it look neater. So if we say, instead of map, we say pluck, and then all we need to do inside is literally a string of the field that we want to extract, so pluck age. Again, if we wait a second, and then as you can see, it does exactly the same thing. Okay, we'll now talk about the merge and concat operators. Okay, we'll now move on to merge and concat. So we'll import both merge and concat, and we'll also be using the delay operator, which I don't think I have covered as of yet. So, whoops, what am I on about? What am I doing? Example, hopefully I could spell correctly. So we'll go merge. They both do similar sorts of things, but in the sense how they, oh yeah, we also need the of method as well to actually create an observable just from a single value like so. Again, I already covered the of method beforehand, and now obviously because it's an observable, we get access to the subscribe method and the pipe method, which is what we'll be using in this case. And the reason why I chose to use the delay operator is because you can delay an observable from when it gets emitted. So if we subscribe, so that we can actually see when these values are getting emitted. With the merge, these two will get emitted first, and then it will delay 1000 before doing the first one, and that's because they all get emitted at the same time. So their order is essentially based off of the delay. However, if we use concat, the order is actually based off of the order that we use the observables in the concat method. So if we refresh, as you can see, nothing, and then we wait, and then immediately, because there's nothing delaying these two, it comes immediately after, but not until the first one in the concat method is has been emitted, and you know the delay obviously has run out. So those are the differences. I hope the difference is clear to you on that one. We will now finish off the video by talking about the various map methods, also operators, the various map operators. Now there are a lot more. I mean, it's voluminous how much content there is in RxJS and the other ReactiveX libraries. However, this is basically just a quick introduction video. so we won't be covering everything. Obviously, I think I've given you a good enough introduction. So what the merge map can do, it can replace the data that's currently being emitted in the stream with a completely new inner observable which can be subscribed to. So instead of having to do something like the following, say if we did, because remember from events they take in the actual event as their argument, because there is no clear value. So let me just show you. I don't think I actually showed you that. So that as it takes in the current event as the actual data that's being emitted. So say if we wanted an inner observable inside here, say if you wanted to make a AJAX request to a server or something, so we'll create a new observable in here, then we'll have to subscribe to it just to receive its values. So having two subscribe method now, and one is an inner observable inside this outer observable because that's when it's called. So now if we click, as you can see, we click and then we get the inner observable being called, and then we click again and then it will interfere, and then yeah, so things are starting to get a bit wacky now because you keep on clicking, but essentially you get the idea. And instead of this messy code here, what we can do is that we can use the merge map. So what we'll say pipe, because obviously it's an operator, merge map, and then inside we're going to have to return an observable. I remember EJS syntax is when if you don't have any curly braces, then it automatically returns whatever value that we had here after the arrow. So we'll do exactly the same thing, and then we can simply have one subscribe method, because the event that was originally emitted by this observable will now meet the merge map operator, and then immediately it will get replaced with this new observable. So this is how you can completely replace the data that was originally being sent. It's disregarded now, the data that was originally sent down the stream and being replaced entirely by this completely new observable. So that's how you can do what we couldn't do with the original map operator, where we could only modify the data that was being originally sent, but we couldn't completely replace it with something. So now we'll do the same, like so. So now if you refresh, again you click, again now we're getting the interval, and again you click again, things will start to get, again the same logic will happen. But there is another, well there's actually several more, I don't think we'll talk about them, but we'll talk about the some of the main ones. And the next one that we'll talk about is switch map. And what switch mappers do, switch map will do, it only allows one inner observable in the stream at a time. So as soon as we click again, it will disregard the old inner observable and replace it with the new inner observable that we've just called. So if we click, then obviously, and then if we click again though, then it will just restart the time. As you could see, it restarts. So this is an important distinction to make when making HTTP requests. Just note that if you do get a new inner observable before the previous one has, before the server has returned a value for the previous HTTP request observable, then it will just be completely cancelled, and that HTTP request will just be completely cancelled, and it will never be, the server will have never had the opportunity to have returned a value. So that's just an important distinction to make between these two very popular map methods. And there are more methods, map methods to talk about. I'll talk about exhaust map now. And what exhaust map will do, it literally, unlike switch map, it will literally physically prevent another inner observable from entering in the stream until the current inner observable has finished. So the way that I'll show this off, I'll use the take. Obviously we need to, because we don't have switch map anymore. So we'll say, we'll put a pipe on this because it is an observable after all, so we can do that. We'll take 5. So now I have to wait for this interval to complete before we can even trigger a new one. So if I can show you. So we click one, and we click again, you know, it's still counting down even though we clicked again. And then when we click again, we can only restart it now by clicking once it's finished. So that's how exhaust map happens, hence its name. I mean, the name's kind of a giveaway, to be honest. The last one that I'll talk about is exhaust map, and not exhaust map, concat-map, and to demonstrate the difference between concat-map and the map method that's most similar to, and that's merge map. I use them both as an example. Hopefully we have of, no we don't, so we'll need to bring it in. So here is our source observable. And then for this one we will use concat-map, and actually the name's quite a giveaway because you already know the difference between map and concat, or you should if you were paying attention. So, and then what we'll need to do, so this is milliseconds, and then we'll need to bring in pipes that we can delay it. Sorry, not pipe, that's already on all the observables anyway. So we'll include the delay in here, and we will delay it by the value that's currently being sent in the stream to this operator. And what will happen here is that even though 1000's got a longer delay than 2000, obviously 2000 will still be logged first, simply because of how concat-map orders things, how orders the most important to it. However, merge map, the opposite will be true. And again, the same reason for the difference between map and concat. It will 1000 will be before 2000 because all the inner observables get sent at exactly the same time, and it's up for the delay to configure the order of things, not the actual delay that we used in the merge map method, unlike concat method. So anyway, that's it for this tutorial, guys. After you finish this tutorial, I recommend that you check out subjects because that's another topic. And then you can just go on from there and read in the documentation for the things that I didn't cover in this tutorial. But I wanted to keep things short and snappy for this one. And I think I've covered the basics. So I hope you benefited from this tutorial, and I hope you consider liking and subscribing if I did benefit you in any way. If not, then please post down in the comments box below on what you need further help with, and I'd be very happy to help you in the comments box below. But anyway, have a great day, guys, and peace out.